Alright, a member of the group has posted a very interesting maths problem here for us to try and solve. So let's have a look at the question. The diagram shows the flag of a new country. Each rectangle is to be colored either red or black, but the flag is not to be totally red or totally black. The number of different flags which can be made is... Alright, so the first thing I've done is I've labelled the small rectangles inside the flag. Numbers 1, 2, 3, 4, 5. Okay, so we can easily track them. Alright, so what I would do to solve this first of all would be to make a list. So let's first count the number of black flags, or flags that would be partly black. Alright, so we'll start off by just changing the colour of one of the smaller rectangles to black. Alright, and we'll keep track of that. So we'll say we'll change number 1 to black, keep all of the rest red, change number 2 to black, all of the others would be red, change 3 to black, all the others would be red, change 4 to black, all the others red, and so on. Alright, and that would give us a total of 5 flags where one of the small rectangles is black. Alright, let's go down. Now let's try and make 2 of the rectangles black. So we'll start with 1, 2. We'll make 2 adjacent rectangles black. 1, 2. We could do the same with 2, 3, 3, 4, and 4, 5 going across there. So that gives us another 4. I'll just move that over there. Right, now we want to do ones made up of 2 that are not adjacent, so let's work from left to right. We could make 1 and 3 black, 1 and 4 black, and 1 and 5 black. And that gives us another 3 going down. So we've used 1 pretty much up with all the other combinations, so now we move across to 2. We could do 2, we don't need to do 2, 3 because we have that in our adjacent list. So we do 2, 4, and 2, 5. And they're the only 2 you can do there. So that gives us another 2. Now we go across to 3, and we don't need to do 3, 4 because it's already in our list here. So we just have 3, 5. Only 1, that's the only one we can do there. Can we do anything for 4? No. Why not? Because we've already got 4, 5 in our list here. Alright, so how many more did we have there? 4 plus 3 plus 2 plus 1. That's another 10 made up of 2. Alright, now I just paused the video there for a moment to put a quick table in to make working out a little bit easier. So I'll just add over here. So we had 5 rectangles made up, where there are 5 flags, sorry, where there's 1 black rectangle. Then we've had another 10 where there are 2 black rectangles in some formation. So in total now we have 10 plus 5, 15. Alright, now we move over to 3 groups of 3 rectangles. So let's start with the adjacent ones. 1, 2, 3. They would make all those black. Move across to 2, 3, 4. Make all of those black. And 3, 4, 5. Alright, now we stay starting at 1, but now we need to find all of the ones that are not necessarily adjacent. So we go 1, 2, 4, and 1, 2, 5, including 2. Let's move across now to 1, 3, 4, and 1, 3, 5, and now to 1, 4, 5, and that should be all of the ones we can do for starting at 1. So let's put equals. There's 3 there, and here, how many do we have? 5. Alright, and down to that. So now we've done all the ones starting with 1, so we get a 2. We don't do 2, 3, 4 because we've already done it, so we go straight to 2, 3, 5, 2, 3, 5 black, and 2, 4, 5. Can we do any more starting with 2? Doesn't look like it. So we'll, whoops. Say there's 2 there. Now we start at 3. And actually, as I say that to start at 3, obviously we can't, because the only one you could do is 3, 4, 5, and we already have that in our consecutive numbers. And we can't start at 4 because that would only give us a maximum possibility of 2 rectangles. So now we go to the 4 rectangle, 4 black rectangles. So we go 1, 2, 3, 4, and 2, 3, 4, 5. Those are the 2 consecutive ones. 2. Now we need to do the non-adjacent ones. Start at 1 still. We go 1, 2, 3, 5. Any other possibilities starting with 1? Yep, 1, 2, 4, 5. And that gives us another 2. Try to keep this reasonably lined up. Okay, is there anything else we can do? 1, 3, 4, 5. Alright, so we skip the 2 out and we put 1, 3, 4, 5. We can't possibly do any others made up of 4 black rectangles. Alright, so let's count those up. 3, 8, 10, 12, 14. Wow, I got 15 on both sides. Right, nice symmetry, which would give us a total 30, which is in the answers. It's answer A. And this actually makes a lot of sense, because if we were to go through, see all of these ones made up of 4 black rectangles will actually correspond to the ones the ones with the 1 red rectangle, if we were to flip this whole thing around, right? So these ones, if we had done red instead of black, would have been over here then. They would have been, you know, 1 red would have been 2, 3, 4, 5 black, right? So it makes sense that it's symmetrical because you need to repeat the process. So yeah, in total, the answer should be 30. Now, it's quite a difficult question, I think. Yeah, so the quickest way to do it would be to make a list like this that I've done.